This is a worksheet on problems where we have ion concentrations and we're trying to go from one ion to another. And basically what we're talking about on this worksheet is this equation where we have the concentration of H3O plus, or the concentration of H plus if you prefer, and the concentration of OH minus, and you multiply them together and you get 10 to the negative 14. This has to do with the autoionization of water, that equilibrium equation that I showed you back in the acid-base notes. And what happens is within water there's this equilibrium between H3O and OH and just H2O molecules, wherein it's always kept at a concentration where H3O plus times OH equals 10 to the negative 14. And so what we do here is basically on all of these problems just take 10 to the negative 14 and divide it by whatever concentration we're given, and that gives us the concentration of the other thing. So for instance here, on this first one, it's asking us what the hydroxide ion concentration is, so we want to know what OH minus is. That simply equals 10 to the negative 14 divided by our H3O concentration there. So we'll say this H3O plus, okay, which equals 10 to the negative 14 over 5.29 times 10 to the negative fifth. Now, many people, when they're doing this, they screw up at putting it in their calculator, so make sure that you're putting this in your calculator correctly. You either need to use this capital E function here to keep it all together in the denominator, or you need to use parentheses or something like that, but make sure that you're calculating it correctly, because otherwise it's totally wrong. The answer is going to come out wrong. So we plug that in, and on this first one, I get that the concentration of OH equals 1.89 times 10 to the negative 10th. And it's going to have units of molar, because in this whole unit we're talking about molar concentrations. Alright, number 2, this one's asking us for the hydronium concentration, but it's exactly the same thing. We're just switching places here. So you know concentration of H3O plus equals 10 to the negative 14 over the concentration of OH minus. And then just plugging numbers in here, 10 to the negative 14 divided by 8.25 times 10 to the negative 2. Plug that in. You get 1.21 times 10 to the negative 13 molar. By the way, I should mention with sig figs on these, that 10 to the negative 14 is considered to be sort of one of those perfect sort of numbers. And so we're going to go with, on sig figs, whatever we put in for the sig figs, we're going to get out for the sig figs. So both of these have had 3 sig figs with the concentrations that they've given us, so we'll have 3 sig figs coming out. Question 3 is asking us for hydroxide, so this is just like problem 1 again. So we're going to take 10 to the negative 14th, divided by what they gave us there, 1.25 times 10 to the negative 3rd. You calculate that, and you get 8.0 times 10 to the negative 12. 8.00 times 10 to the negative 12 molar. On number 4, asking for hydroxide again. So on this one, it's asking us for hydronium, but it's just like number 2. So we get 10 to the negative 14 over what they give us, 6.48 times 10 to the negative 7. All right, plug that in. You get 1.54 times 10 to the negative 8th. Molar. All right, on number 5, this one is asking us for hydroxide ion, giving us hydronium, so this is like numbers 1 and 3. We get 10 to the negative 14 over what they gave us there, 6.4 times 10 to the negative 13. This one has 2 sig figs. So we should have 2 sig figs in our answer. So it gives us 0.016 molar. I just chose not to use scientific notation on that one because it was pretty much just shorter to write it out in standard notation. For this last one, so same deal, 10 to the negative 14th. This one's asking us for hydronium. It's given us hydroxide, so 10 to the negative 14th divided by 1.89 times 10 to the negative 3rd. Go through, calculate that. You get 5.29 times 10 to the negative 12 molar. All right, that is that. Those are pretty simple, and that kind of wraps up all the different calculations that we do with pH and concentration of OH and concentration of H3O plus and POH. So look at this one and the worksheet on the pH calculations, and you should be pretty good to go.